My name is C. Bhuvan Krishna, working as an assistant professor in Anandapur Institute of Technology, Anandapur. Today I am going to discuss about the topic of two-port networks, which is very useful in communications, control systems, power systems, electronics, and it can commonly used to model the voltage and current characteristics of complex electrical circuits, and it is mainly can be used in mathematical circuit analysis techniques to isolate portions of larger circuits which can be used as an cascaded networks. Now let us see what is the definition of a two-port network. A two-port network consists of two terminals. One is input terminal, other one is output terminal. Now let us see what is meant by port. A port is a pair of terminals in a network at which a signal enters or leaves, is known as at a network. Okay, right. Now, what is meant by single port? What is meant by a single port? A single port nothing but this is a single port. A single port is nothing but where current enters in one direction and same current leaves in other direction, where sigma I is equal to 0. Where sigma, these are single port network where the same current enters from one side, another the same current leaves at other side. Therefore, this is a two-port network where one current enters from input to the network, another current entered output from the network. Now, let us see what are the parameters of the network. Now, the two-port network is generally classified as the four types, which are Z parameters, admittance parameters, transmission parameters, hybrid parameters. Now, impedance parameters nothing but Z is equal to V by I, where Z is the impedance. Units of impedance is ohms. Units of impedance is ohms. So Z is equal to Vi. Therefore, we can write V is equal to I into Z, where V is considered as an V1 and V2, and I is considered as an I1 and I2. Generally, we have four variables that are V1, V2, I1 and I2. Therefore, we will have 6 combinations. Let us go for Z parameters. As Z is equal to V by I, it is considered in the equation V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Now let us go for the equivalent circuit. Now V1 is equal to Z11 I1 plus Z12 I2. Now consider this in equation. Here in LHS we have voltage. In RHS this is considered as an V1 dash. This is considered as V2 dash. Now equivalent circuit will be, this is your V1. This will be your I1. This will be your Z11. This will be your Z11. Now let me clear this one. Let me take a page. Now let me draw a equivalent circuit here. V1 is equal to Z11 V1 is equal to Z11 I1 plus Z12 I2. Now let us take another equation. V2 is equal to Z21 I1 plus Z22 I2. Let us draw the equivalent circuit for that. Equivalent circuit. Now here LHS is nothing but a unit of voltage. Therefore the LHS must be equal to the RHS. Now this is your V1 voltage. This is your I1. Now this is your Z11, which is nothing but Z11 I1. Let us it is a voltage. Now this V1 is depending on Z12 I2. Therefore let us take this one, Z12 I2. Now as this is a product of voltage, we will consider it as a voltage source. Right? Now coming to the second equation, this is your V2. Now this is your Z22. This is your I2. Now it is depending on Z21 I1. This will be your equivalent circuit of Z parameters to Z parameters. Now when I2 is equal to 0, we will get the parameter of Z11. When I1 is equal to 0, we will get the parameter of Z11 and Z21, where Z11 is considered as an input voltage, where port 2 is an open input impedance. Z11 is considered as an input impedance and Z21 is considered as an forward transfer impedance. Now Z12, when I1 is equal to 0, we will get the parameters of Z12 and Z22 when I1 is equal to 0, where Z12 is nothing but V1 by I2 and Z22 is equal to V2 by I2, where Z21 is considered as a reverse transfer impedance and Z22 is considered as an output impedance. Okay. Now let us solve some problem regarding Z parameters. Let us take this one as a Z parameters example. Before that, let us go for T parameter, T network. This is your Z1, this is your Z2, this is your V1, this is your V2, I2, I1. Let me take this as Z3. Now we have to find the Z parameters. We have to find Z parameters. Now let us solve this by considering we can solve this problem by taking the currents as 0 or by using KVL equations. Let me use taking currents as 0. When I2 equal to 0, we will get V1 is equal to Z11 I1. Next, V2 is equal to Z21 I1, where Z11 is equal to V1 by I1, Z21 is equal to V2 by I1. We will get the circuit like this is your Z1, Z3, V1, I1. So this will be your V2. This will be your V2. Now what is V1 by 1? V1 by 1 nothing but we can consider as Z equivalent, which is nothing but Z1 plus Z3, and V2 is equal to I1 into Z3, because here also the current flowing is of I1. Now what is Z11 from the above equations? Z11 nothing but V1 by 1. Therefore that is your Z1 plus Z3. Now Now Z21 is nothing but V2 by 1, which considered as Z3. These were Z11 and Z21. Now let us calculate other parameters considering I1 is equal to 0. Now what will be the circuit when I1 is equal to 0? There will be a voltage source of V2, current of I2. As I1 is equal to 0, these were Z2, these were Z3. This will be your V1. Now what will be your V2 by 2? Can you tell me? Z2 plus Z3. Now what is V1? I2 into Z3. Now when I1 is equal to 0, we will get the parameters of Z22, which is nothing but V2 by I2. Therefore that is equal to Z2 plus Z3, and Z12, which is nothing but V1 by 1, it is nothing but Z3. Okay. Now these are the parameters we are going to get for T network. Nothing but for T network of Z1, Z3, Z2, V2, V1, I1. Now V1 for this network, Z parameters are given by Z1 plus Z3. These are Z11, Z3. These are Z12, Z3, Z2 plus Z3. These are Z parameters related to T network. Now let us consider for symmetry. Symmetry is nothing but V1 by I1 is equal to V2 by I2. Nothing but Z11 is equal to Z22. This is the condition for symmetry. Now let us go for reciprocity. For reciprocity, according to reciprocity theorem, V1 by I2 is equal to V2 by I1. Nothing but Z12 is equal to Z21. This is the condition of Z parameters for reciprocity condition. Now this is the class today for Z parameters. Now in the next class we will solve problems regarding Z parameters, and we will continue with respect to Y parameters. Thank you.